Okay, الكاتاليست is a chemical that speeds up the chemical reaction, but it does not take a part of it. It means that if I added a certain chemical to speed up the chemical reaction, this chemical will not be used up in the chemical reaction. Type. The enzyme is a catalyst, but in living organisms. But why? Why do we need a catalyst or something to speed up the chemical reaction? And what are the chemical reactions that are found inside our bodies? Remember when I said that there are certain chemical reactions which we call metabolic reactions that happen in the cytoplasm and in organelles, and one of the most important kinds is respiration. Fact. Enzymes, they act like a catalyst in order to speed up these chemical reactions. So why do we want to speed up the chemical reactions? Because if I'm speaking about respiration, مثلا, this is going to release energy. We need energy continuously. If we waited till the chemical reactions of respiration happen in order to finally, where were you, ya Kenzie? Where were you, ya Kenzie? You was disconnected, مش كده؟
Yes.
طب يعني what did you miss بقى من اللي أنا قلته؟
أول بس metabolic reaction.
طيب أنا هنا بقول إن cells they have metabolic reactions, and most important of them is respiration. فلو the cell waited for all the respiration reactions to happen in order to produce energy, we are going to wait for a very long time. The presence of the enzyme will speed up these respiratory reactions in order to allow us to gain energy very quickly, because when we cannot remain without energy for a few seconds. In order to be able to release, or for the cell to release energy very quickly, the enzymes must act in order to speed up these chemical reactions, and the same goes, or the same is true for all the other metabolic reactions. يعني مثلا photosynthesis, it produces glucose and oxygen. Glucose is always needed by the plant. If the plant waited for all the chemical reactions of photosynthesis to happen, the plant will wait for a very long time. That's why enzymes are there to speed up these chemical reactions to allow the plant to have glucose all the time. And the same for energy as well. يمكن أنا when I was explaining in chapter 1, I mentioned that photosynthesis or respiration, they are a group of chemical reactions, not only one as we used to write it. ودي أنا قايلاها وموجودة طبعا على الفيديوز if you want to make a review about what I said. الإنزيم, because it works in living organisms, so I call it the biological catalysts. Biological, why? Because it works in living organisms. So all enzymes, they are biological catalysts. طب عبد الرحمن, what is the enzyme formed of? Which chemical? يلا. I just mentioned it. What's the chemical that forms the enzyme? Excellent. Proteins, طبعا. All enzymes are protein in nature. It means they are formed of proteins. طب مين اللي بيخلي البروتين ده يبقى enzyme كده؟ The code on the DNA. Okay. طيب في ايه تاني؟ طبعا all enzymes, they speed up metabolic reactions. They all have the same properties, by the way. Speed up metabolic reactions. What else? Of course, these metabolic reactions or these chemical reactions that happen inside the cell, they are very important to keep us alive, whether animals, plants, whatever. Type. What is the mode of action of these enzymes? الانزيمز يا جماعة, either they break down or build up. I'm going to give you examples now. Or build up molecules. Type. Let me give you an example. For example, photosynthesis, and you are going to tell me whether this is a building up reaction or a breaking down. Carbon dioxide plus water. Prepare yourself, Veronica, will give me glucose plus oxygen. Is this a building up or a breaking down reaction? ايه رأيك؟
Building up.
طبعا building up, because the plant used small molecules to build up this very large molecule. So this is a building up reaction. Kenzie, glucose plus oxygen will give carbon dioxide and water together with energy. Is this a building up or a breaking down reaction?
A breaking down?
طبعا, excellent. Because a large molecule was broken down into its components. طبعا, Abdurrahman, if I have a protein and I will change it into amino acids, is this building up or breaking down? And I'm going to open the chat again. Is this building up or breaking down? طبعا, bravo. Because a very large molecule was broken down into its components, which are smaller molecules, وبالتأكيد the opposite is building up. طيب. Remember when I was explaining the sugars, I said that every sugar must end in O's, this suffix. Glucose, lactose, galactose, fructose, sucrose, all end in OSE. The enzymes, they end in ASE, A's. So if I have, I want to break down a lipid اللي هو الفاتس, so the enzyme is lipase. If I want to break down, for example, sucrose, the enzyme is sucrase. If I want to break down maltose, it is maltase. But what if I want to break down starch? هل هيبقى starchase? No, it is an enzyme called amylase that breaks down starch. طب where does this come from, amyl? Because starch, the scientific name of starch is amylum. That's why its enzyme that breaks it down is amylase. And of course, there are hundreds of enzymes that are needed for different kinds of chemical reactions, and always the enzyme is named by the material that is going to work on. Sucrose, so it has sucrase enzyme. Maltose, it has a maltase enzyme. Can a maltase enzyme break down مثلا sucrose? Never. That's why we say that the enzymes are specific. What's the meaning of specific? It means that each kind of enzyme has its own molecule to work on. It can never work on any other molecule. يعني لو أنا عندي مثلا starch, الإنزيم بتاعه amylase, it will not work on protein. Okay? طيب في بقى example هنا I'd like to mention. البروتين يا جماعة, the enzyme أو the group of enzymes that break down proteins, they are all called proteases. يعني protein وAs. These are groups of enzymes. عندي منهم 3 of them. One of them is working in the stomach, one is working in the first part of small intestine, and the third one working in the last part of the small intestine. طبعا we are going to know all about this لما أشرح digestive system. But right now you have to know that these information about the enzymes. طيب. Let me give you some examples. طبعا احنا أخذنا خلاص and you have answered my questions about the building up and the breaking down. Let me give you some examples of enzymes, for example. Yani, for example, when we eat food, what happens to the food inside our digestive tract? Digestion. Digestion is a breaking down reaction. Yani, if I am eating, for example, starch, when the starch is digested, it's going to be digested by the amylase enzyme into maltose. Is the maltose a monomer or a very small molecule? No, there is a smaller molecule that formed the maltose, which is glucose. Remember when I explained the disaccharides and I said maltose is formed of 2 glucose molecules? This means that maltose is not the end station for digestion of starch. There is something simpler than maltose. So I have to use another enzyme, maltase. And this happens in our digestive system. But let me give you another example. For example, if I'm eating fats or lipids, as I told you before, they are lipids and fats are parts of lipids. So I need lipase enzyme to break down the lipids into ايه بقى يا كنزي؟ Lipids are broken down into their components. What are the components?
Glycerol and fatty acids.
Very good. Thank you. And fatty acids. طيب, what about the proteins, ya Veronica? Proteins, they are broken down by proteases in different parts of the alimentary canal to change into proteins. They change into
is it amino acids?
Excellent. طبعا amino acids, of course. Thank you. This means that digestion is building up or breaking down. طبعا breaking down. Because when we eat starch or lipids or proteins, we are eating biological molecules, we are eating very large molecules, and they have to be broken down in our digestive canal. And they are broken down, of course, by certain chemical reactions, but the enzymes, they speed up these chemical reactions. But this is for animals. Let me go for plants, مثلا. And plants, for example, remember the cotyledon that I explained before, when I said that there are 2 cotyledons or even 1 cotyledon, and there is an embryo here, and this embryo has to grow in order to give me a new plant. I said before that in these cotyledons there are storage, or they act as storage parts of the seed for storing starch. And I said before that this starch is stored for the growing embryo to feed on. When we germinate the seed, or when we put it in the soil and add water to allow a new plant to be produced, so this embryo has to feed until it gets out the leaves and be a small plant. This embryo, it's going to feed on the starch components of the cotyledons. طيب, will the embryo eat or feed on the starch? No. When we add water, so when we soak يعني the seeds with water, بيكون inside there is an amylase enzyme. And remember when I said amylase enzyme is used to digest the starch. So when we add water to the seed, or when we soak the seed in water, this amylase that is stored inside the cotyledon is going to be activated. Okay, it is as if it was sleeping, and then when we added water, it woke up. Amylase, it is activated, so it starts to break down this starch into maltose. طيب, يبقى معنى كده ان الجروينج امبريو is going to feed on this maltose. طيب, I want to ask a question. Why the embryo did not feed on starch على طول? Why it has to wait till the starch changes into maltose? Can anyone give me a hint كده? What do you suggest? Why the embryo did not feed on starch as it is found already? Why it has to wait for this starch to change into maltose? I want you all to think. Any suggestion? No suggestions. طيب, بصوا بقى. الامبريو يا جماعه in order to absorb this food يبقى it absorbs the food that is soluble in water. طب is starch soluble in water? No, it isn't. But maltose is soluble. So the embryo has to wait till a chemical is produced that can dissolve in water so the embryo can absorb this food. That's why the starch will change into maltose, because maltose can dissolve in water, so the embryo is going to absorb this maltose in order to feed on and starts to grow. Okay, that's why the embryo does not rely on starch. لا, أيوة, there is stored starch in the cotyledon, but when the embryo is beginning to grow in order to form a new plant, it has to wait for this starch to change into maltose. Will it wait for a long time, يا كنزي? Well, it will not wait for a long time.
It will not wait for a long time because of the catalyst.
طبعا. طب والكاتاليست ده سميناه ايه بقى؟
Amylase.
Amylase enzyme. Okay, excellent طبعا. فكده الامبريو is going, it's not going to wait for a long time because this enzyme will speed up the digestion of the breaking down of starch into maltose. طيب, let me explain something else. عبد الرحمن, what is the maltose formed of? Maltose, نفكر فيها كده. This is a disaccharide. It means that it is formed of monosaccharides. طب what's the monosaccharide that forms maltose? You remember from last session? لا, خلي بالك. Maltose is formed of starch. But my question was, what is the maltose formed of? If I'm breaking down this maltose, what's going to be released? Maltose is a disaccharide. It means that it is formed of two monosaccharide. Of course, yes. Two glucose molecules. طب انتوا عارفين الجلوكوز ده البلانت هياخده يعمل بيه ايه؟ It will form from it the cell wall. طيب, who remembers, يا فيرونيكا, what is the material that forms the cell wall? Cell wall is formed of which chemical? In plant cells, what's the cell wall made of?
Cellulose.
Cellulose. Yes, very good. Very good. Yep, I'm going to erase this question mark and I will write cellulose. But what is the cellulose formed of? It is formed of glucose. طب الجلوكوز جه منين وده؟ It is still an embryo. جه من المالتوز. When the maltose was broken down by maltase enzyme that is also found here, So glucose is going to be produced, and this developing embryo is going to form so many things with this glucose. But the most important is the formation of the cell wall, because the embryo is going to develop into a plant. So what is the plant formed of, ya Kenzie? Plant A?
Miss, what do you mean?
In the whole plant, what is it formed of? What is the main building unit of the plant? What is any organism formed of?
The cells?
Cells طبعا. يعني in order to be changed from an embryo to a plant, it has to build the plant with cells. طب ما هو الcells دهيت it needs cell walls. Okay, these are plant cells, that's why the embryo will form. من الجلوكوز ده كمان يعمل منه cellulose in order to form the cell wall. طيب I'm going to give you another example for enzymes, وده مهم قوي قوي قوي، وفور يعني it's very important for paper 6 بالأكتر. There is a very important enzyme in all animals and all plants, very important, which is called Catalase Enzyme. طيب من اسمه كده we cannot know what is the material that is going to work on. The catal جاية من catalysis or catalyst. Catalase. طب which material is it working on? بصوا بقى يا جماعة. For any living cell, plants or animal cells, لما بتعمل metabolism, I told you before that any metabolic reactions must result in A, Abdurrahman, something useful, and what is the other harmful material? Give me a name. Give it just one word, Ya Abdurrahman. The harmful materials that result from metabolic reactions, they are all called مش لازم toxins. هي طبعا هنا it is a toxin بالتأكيد، بس let us say waste. Okay, and one of the wastes is toxins. دايما metabolic reactions whether in animals or plants they produce فعلا التوكسين، والتوكسين ده do you know what is this? You have to know it بقى. Something called hydrogen peroxide. الفورمولا بتاعتها H2O2. ف whenever there is a metabolic reaction in animal or plant cell, this hydrogen peroxide must evolve or must be released, and this is a toxin to the cell. That's why it has to be broken down at once by this catalase enzyme. So this catalase enzyme, it's going to break the hydrogen peroxide into useful components, which are water and oxygen. Of course, the cell needs oxygen, the cell needs water. These two chemicals, the water and oxygen, they are produced after breaking down of this toxin. It means that this catalase enzyme is very important to the animal and plant cells because it changes something toxic into useful materials. This is very dangerous, by the way, if there is no catalase enzyme, this toxin is going to accumulate inside the cell and the cells will die. So that's why as soon as it is formed, it has to be broken down immediately. That's why the catalase enzyme is found in large amounts in our cells, whether animals or plants. طيب. All what I explained now, سواء بقى digestion, what happens in plants, the changing of starch into its components, changing of maltose into glucose, and this one, all these are breaking down reactions. As you can see, the H2O2 or the hydrogen peroxide was broken down into water and oxygen. الdigestion كلها breaking down reactions, even in the plant. The starch was broken down into maltose, and the maltose was broken down into glucose. All these are breaking down reactions. let me give you examples for building up reactions بقى. Building up reactions that in which the enzyme is involved in. مثلا for example, building up معناها that we are building large molecules from smaller ones. طيب, let me give you an example. If I want to build starch from glucose, immediately كده بقى, to form starch. يعني when I want to break them down, I have to break the starch at the beginning to maltose and then from maltose to glucose. But what if I want to change the glucose or to build up the starch from glucose molecules? وعلى فكرة, the starch, as I mentioned before, is made of loads and loads of glucose molecules. There is an enzyme that's called starch phosphorylase. This enzyme, it builds up the starch from glucose molecules, but not in animals. مادام الاقي building up of starch يبقى in plants على طول. طيب كنزي, what is the chemical in animal bodies that يعني in plants بتبقى فيها starch. طب what about in animals?
Glycogen.
Glycogen. Excellent. Bravo. طيب خلاص, يبقى كده this is an example of the building up reactions. Now, how do the enzymes work? How do they work? أو the mechanism of action of enzymes. How do they work exactly? بصوا, we all know the puzzle. Okay, البازل بتبقى عاملة ازاي؟ أنا عندي كده for example a shape like this, and I'm going to put a shape that completes it, opposite to it, where we say that this is complementary to this. Remember the word complementary? Means they can fit with each other. So this is the mode of action of the enzyme. بلاقي in enzymes, they allow the molecules of the substance to fit into them. أنا عارفة اللي هتقولوا لي إيه. Yes. Well, I knew إن عبد الرحمن اللي بيكتب without seeing the chat. Okay, yes, very good طبعا. But let me explain it bit by bit يا عبد الرحمن. If you can see here that this, for example, this is, for example, starch. So it's going to fit in this shape. مثلا يبقى this enzyme is amylase. It means that amylase has this shape and the starch has the opposite shape. But let's change the material of the substance. For example, sucrose. Sucrose looks like this, for example. For example, will I use an enzyme that looks rounded from here? No, I'm going to use a shape or an enzyme that has the opposite shape, complementary to it. This means again that the enzymes are specific. Remember when I said that each enzyme works on a certain substance? لأن each enzyme has a certain shape in which the substance can fit in. Fitting of substances in enzymes, this model or mechanism is called the lock and key. Lock and key mechanism or lock and key model. Yani if you have a lock like this, and here is the opening of the key, can any key open the lock? Of course not. There is a specific key that's going to enter to, and when you turn the key, it's going to open the lock. Suppose this lock opens by a key that looks like this. If I used a key that looks like this, will it open this key? No, never. This means that every key, it has a certain shape that is complementary to the shape inside the lock. And here is the same. The enzyme, it has a certain shape, and the substances are going to fit in this shape as if it is a lock and a key. This is what's meant by the lock and key. Always the lock is the enzyme, while the key is the molecule that's going to allow this enzyme to work. Why enzymes, they work on certain substances? Because the shape of the molecule of the enzyme is complementary to the shape of the molecule that it is going to work on. طيب, I'd like to show you a picture كده, وفي النوتس أنا حاطة برضو البيكتشر مختلفة. أنا يعني in the notes I used a picture from Cambridge book, لكن this picture I got it from Google, بس طبعا both of them are correct. ثواني بقى عشان I forgot to open this folder. Just a second to get the folder. Enzymes. Yes, here are they. This is the folder of the enzymes. Enzymes. Okay, here is the picture. Look at this. No, it's not the one. This is not the one I wanted. لا ثانية واحدة بقى. I got you الفولدر بتاع ال AS. I'm so sorry. دقيقة واحدة يا جماعة. Yes, here it is. ده OL كده. This is the picture. I was teaching AS in the morning and I added the folder. بصوا كده البيكتشر دي. Now, suppose that this is the enzyme here, okay? And this is the molecule that it's going to work on. Look at the shape of the enzyme and look at the shape of the molecule. Of course, if this molecule, it will fit in the enzyme, yes, it's going to fit. If the enzyme is okay, or has the complementary shape to the shape of the molecule, so the molecule is going to fit in this, and then the enzyme is going to work. يعني هنا بصوا للcolors. طبعا it's not colorful in our bodies, but it's just for demonstrating. If I have here a molecule that looks like this, here the enzyme started to work. That's why it is breaking down this molecule. So at the end, the products are released. Did the enzyme change? No, it didn't change. It is the same here as in the beginning. This means that it is a catalyst that did not take a part in the chemical reaction. Remember when I said at the beginning that the catalysts, they do not take a part of the chemical reaction. Look at this. This was the enzyme at the beginning, and at the end, it still looks the same. But what has changed? The molecule on which it acted. So when the enzyme acts on a certain molecule, the molecule, we give it a name, the substrate. Type. Suppose this substrate is sucrose. Veronica, what's the name of the enzyme now that's going to work on this sucrose? Suppose this is a molecule of sucrose. So what is the name of the enzyme? You just take the name of the substrate or the molecule on which it acts, and we add E, which suffix?
Sucrase.
Sucrase, very good, very good. So if I'm using sucrose as a substrate, so the enzyme is sucrase, of course. Type. When they bind together, we call this shape the enzyme substrate complex. Okay? Type. Kenzie, after working of the enzymes, what are these products? What is the sucrose formed of?
The glucose and
Yes, and?
fructose.
Fructose, yes.
Yes.
بغششك. Okay. Here the enzyme sucrase broke down sucrose into its components اللي هم fructose and glucose. طيب. Do you know that if I want to, I will erase all this. Suppose I have the products glucose and fructose, and I want to bind them together to form sucrose. Again, we are using the same enzyme, but in the opposite direction. This means that the enzyme can break down and it can build up as well. So this action is called reversible action. Most enzymes, by the way, they have a reversible action. Yani if I want to break down a substance, I use a certain enzyme. If I want to rebuild the substance again, I'm using the same enzyme. So the enzymes, most of them, they work reversibly. Yani the ones that break down are the ones that are going to build up like here. But of course, this is not the case in all enzymes. Yani they are not all reversible. اللي حابة أقوله هنا in every enzyme has a certain shape on which the substrate is going to lock. This shape is the working part of the enzyme. يعني the rest of the molecule, which is protein طبعا, the rest of the enzyme molecule is not working. It is only this shape, and this shape is called the active site of the enzyme, or the active place of the enzyme, or the active part. It means that all the enzyme molecule is not active, it's not working, it's only this part. That's why we say that this part is the active site of the enzyme. Whatever the site looks like, يعني لو أنا عندي مثلا an enzyme that looks like this, for example, الactive site بتاعتها looks like this. So this is the active site. Why? Because the substrate is going to have complementary shape to this active site in order to allow the enzyme to work. Okay? For every enzyme, there is an active site that is completing the shape of the substrate molecule, and that's why we say that the active site is complementary to the shape of the substrate. طيب فالديفرنس أو the different active sites will make the enzymes specific طبعا. Again, let me remind you what's the meaning of the word specific. It means that every enzyme has its own substrate to work in. بمعنى تاني, I give you an example that this substrate is sucrose. So I use enzyme sucrase. طيب أسأل عبد الرحمن, if the substrate was a protein, so what is the enzyme for protein? It is called protease. Excellent. طب Kenzie, if I want to build up lipid from glycerol and fatty acid to give lipid, which enzyme I'm going to use?
Miss, I'm a little bit confused with the reverse action.
لا هي نفس الانزيم. بصي طب انا هقول لك حاجه. If I want to break down the lipid into fatty acids and glycerol, which enzyme am I using? I will break it down. Lipids will be broken down into glycerol and fatty acids. باخد the substrate والenzyme, the name is the same, but instead I'm going to add A's. يعني protein, it was protease. Sucrose, it is sucrase. طب what about the lipid?
Lipidase?
لا مش lipidase بقى, lipase. Okay, لا good طبعا, برافو عليك. بس it's the first time to hear about them. فصح طبعا. Why not? Lipase, okay? طيب what if I want بقى to build up the lipid? I'm going to use the same enzyme. Okay? فالإنزيم هنا بقول عليه reversible action. It can break down and it can build up. بس زي ما قلت لكم يا جماعة, this is not the case with all enzymes, but the majority of enzymes they build up and break down by the same enzyme. فبكده قدرنا نعرف ان الانزيمز are specific. وتعالوا بقى نشوف مع بعض. يعني I just give you at the beginning the general properties of enzymes. When I said that all of them, خلوني ارجعها لكم تاني كده. Yes, here it is. And all of them they are biological catalysts. And I said that all of them speed up the chemical reaction. بلاش all of them علشان next year or next course you are going to see that some enzymes slow down. Most enzymes speed up the chemical reaction. All of them are protein in nature. All of them they either break down or build up. All of them are specific. طيب are there other properties to the enzymes? Yes, and it goes with all enzymes. So what are, or in other words, what are the factors that affect the properties of the enzymes or the action of the enzyme? Factors affecting enzymes. عندي حاجتين يا جماعة بيعملوا affection على الانزيم. طبعا يعني بعد كده هنقدر او في النكست كورسز هنقدر نعرف ان هم اكتر من حاجتين. بس in OL that's enough to know that there are two factors that affect the enzyme activity, او بمعنى تاني that affect the active site of the enzyme. لان انا لسه بقول ايه, which part of the enzyme is working? It is the active site اللي عندها a certain shape in which the substrate can fit. طب في factors that affect the enzymes. The first factor is temperature. ده عبد الرحمن ده. أنا عارفة أول ما أقول حاجة ولاقي الشات بيعمل signaling يبقى عبد الرحمن بيقول لي. Thank you عبد الرحمن. Thank you. Excellent طبعا. Temperature أنا هقول اللي أنت قلته بس أنت كتبت pH الأول. Number 2 pH. طيب نشوف الأول temperature and then let's know what's meant by pH and how does it affect the enzyme. بصوا بقى يا جماعة. مثلا in the human body, what is our normal temperature? يا فيرونيكا. Human body temperature. What is our normal temperature? 37. Okay? أو around 57. فبلاقي إن all the human enzymes they work best at 37 degrees Celsius. They work best. يعني إيه work best؟ يعني they work with their maximum effort أو with their maximum effect on the substrate. Substrate يعني إيه؟ يعني the material on which the enzyme acts. all the enzymes in the human body, they work best with their maximum activity at 37. We call this temperature the optimum temperature of this enzyme. يعني إيه optimum temperature؟ يعني it is the temperature at which the enzyme works with its maximum effort. بتديني the best activity at this temperature. طب what about plants؟ البلانتس لا يا جماعه، البلانتس الاوبتيمم temperature بتاعتهم around 27، فده بقول عليه the optimum temperature but in plants. طب what is my conclusion of this? It means that every living organism has its own optimum temperature on which the enzyme act. طب ده يوصلني لإيه يا كنزي؟ هل enzymes الهيومن هم الانزيمز of plants or not؟
No.
No، طبعا no. ودي حاجة من الحاجات اللي بتخلي برضو الانزيم specific، ان the enzymes that work for humans are not going to work the same as they work in plants even حتى لو كانوا هم نفس الانزيمز but they are not going to work effectively at 27 مثلا بتوع humans. They must be at 37 in order to work the best. طيب نفترض ان the temperature was خلينا نتكلم على الهيومنز بالتحديد. The temperature is decreased less than 37. What will happen to the enzyme activity؟ ما دام ال 37 الانزيم فيها the highest activity، يبقى if the temperature is lowered less than 37 هلاقي ان الاكتيفيتي of the enzyme will be عبد الرحمن بيكتب تاني. لا دي كنزي. Yes of course it will have less activity. طيب what if I increase the temperature؟ هيحصل بقى هنا حاجة مهمة قوي.
Denatured.
Yes denatured. عبد الرحمن كنزي سبقتك النهارده دلوقتي يعني. يحصل denaturing to the enzyme. طب let's look at this word nature. The nature of the enzyme. دي يعني the enzyme loses its nature. What does this mean? طب let us see something together. احنا عارفين ان الانزيمز they are proteins. ولو احنا فاكرين ان البروتينز they are formed of amino acids. And remember when I showed you the structure of the amino acid I drew it like this. ان كل amino acid عنده COOH group و NH2 group، وقلت ان دول بيبقوا constant in all amino acids ومعاها هنا السايد chain. فالبارت encircled ده بيبقى constant in all proteins وكمان منهم الانزيمز طبعا. فبلاقي ان الهاي temperature is going to affect these two groups. هتبوظ لي الجروبس دهيت. This means that the total protein is denatured. Another word for denatured, damaged. بس طبعا I always like my students to mention the correct scientific names. If you did not remember in the exam the word denatured, you can just mention damaged. But of course denatured is better because the protein from which the enzyme is formed will lose its nature. طب ايه اهم حاجه في النيتشر of the protein؟ these two groups. ف high temperature is going to break down or to damage these groups, so the whole protein will lose its nature. طيب تعالوا كده نبص على الكيرف ده. دي طبعا a curve that frequently comes in the exams. This is the curve for the effect of temperature على الانزيمز. وانا هنا هسأل بقى. Look at this curve. طبعا look اول حاجه ببص عليها يا جماعه are the information على the x and y axes. When you read a curve اول حاجه to look at the x and y axes. What are written on these? The temperature. Temperature means it is the factor that's going to control the enzyme activity. Temperature will control the enzyme activity. So as you can see that the temperature is varying, it is changing. So I describe the temperature as a variable. Okay, طب what about بصوا increasing enzyme activity? Then again the activity is changing, so this is another variable. طيب Veronica, which variable depends on the other? ايه رأيك؟ Which one of them depends on the other? Excuse me?
The activity of the enzyme
Yes.
depends on the temperature.
Excellent, excellent. So I call the activity of the enzyme the dependent variable. It means that it is depending on another variable. And what about the temperature? I call it the independent. هو ما بيعتمدش على حاجة. It depends on nothing. يعني it is the variable that controls all the activity of the enzyme. Okay? طيب this is بقى the same in all the curves اللي هتشوفوها طول عمركم. اللي مكتوب على الx axis بقول عليه the independent variable, and the one on the y axis is the dependent variable. طيب عبد الرحمن, in your opinion, what is the optimum temperature here? What's the optimum temperature here? وأفكرك تاني, the optimum temperature is the temperature at which the enzyme works the best with its highest activity. Excellent, 40. So because 40, if I followed it, you will find that the highest point of the curve is at 40 degrees. It means that 40 is the optimum temperature at which the enzyme works the best. Type. Look here, if I'm decreasing temperature, what happens to the activity of the enzyme? It is declining or decreasing. When I reach zero, يا كنزي, هل الactivity وصلت لزيرو? Was the activity completely lost when I reach 0 degrees? No. فهنا أقول إيه؟ إن when the temperature reaches 0, the enzyme activity will be the least. طيب سؤال ليكي تاني يا كنزي, when the activity is the least, is the enzyme denatured?
No, it's inactive.
Inactive بس, أو having the least activity. طيب Veronica, what about at 65 مثلا degrees? What happened to the activity of the enzyme? Is it lost or not?
It's lost.
طبعا, because it reached the 0 point. Is the enzyme denatured here or not?
Yes.
Yes, of course. يبقى هنا عندي denatured enzyme. يبقى عندي extremes, denaturing of the enzyme. يبقى the extremes of temperature, they differ in their effect على الانزيم. If the temperature was lower to the least temperature اللي هي 0, so the enzyme was not denatured, but its activity was lower till it becomes the least activity of the enzyme. And the opposite for the high temperature. When we increase the temperature of the enzyme, it starts to decline or to decrease in its activity until it is completely lost. Why? Because there is denaturing of the protein nature of the enzyme, or in other words, the carboxylic group and the amine group are destroyed by this high temperature. I always give here an example. Suppose you have a piece of meat, and of course we know that meat is formed of protein, raw meat that was never cooked. When we buy meat, we just put it in the fridge or in the freezer in order to cool it down. What if I want to cook this piece of meat? I'm just getting it out of the freezer. I'm increasing its temperature, and then I will cook it. It means that this meat is going to work. It is liable for eating. But what if I put the piece of meat on the cook? I start to cook it, and then I left it on the cook until it is burnt. I'm increasing its temperature until it was burned. Am I going to eat it? Will be able to eat it or use it as meat? Never. Why? Because it is burned. It was denatured. It lost its nature. خلاص. But the same for the enzyme. This is a protein. But it acts like this piece of meat. If I want to put it in the fridge or to lower the temperature, this means that the enzyme activity is going to drop until it is the least. But if I increase the temperature once more, the enzyme is going to work. Lekin, if the enzyme was denatured, it will never work again, even if I decreased the temperature. يعني لو أنا عملت increasing temperature after it was cooled down, if I increase the temperature, the enzyme will return to work again. Okay, like the piece of meat. It was freezed, and then when I increased its temperature, or I put it at room temperature in my kitchen or whatever, I can cook it once more. Okay, it's working. But if I burned it or it lost its nature, even if I decreased the temperature, خلاص, it is denatured, it will never work again. But this is for the temperature. طب let's go to the other factor. اللي هو بقى, as عبد الرحمن said, the pH. طب what is the pH بقى? Who knows what's the pH? Who knows this? Do you know? Well, you haven't taken this in chemistry. Right.
Miss, we took it as it's a scale that indicate whether it's an acid or base.
Very good. Or neutral.
Yeah,
right?
or neutral.
طبعا. طيب, the same for the enzymes. The enzymes, they work on a substrate, يا جماعة. But what is again the substrate? It is the material on which the enzyme is going to work, or the chemical on which the enzyme is going to work. This substrate is found in a medium or in a certain place. If this medium is acidic, the activity of the enzyme will differ than if the medium was neutral, and this activity will differ if the medium is alkaline or basic. But what does this mean بقى? Again, each enzyme has its optimum temperature. خلي بالكم عشان هعمل comparison دلوقتي and you are going to answer. Optimum pH. زي ما كان عنده optimum temperature at which the enzyme works the best, the pH can control the activity of the enzyme, and each enzyme has its own optimum pH. Right. I'm going to tell you something. If the enzymes are found in the stomach for digesting proteins, what is the pH of the stomach? Who knows? Is the stomach, inside the stomach, the gastric juice or the digestive juice, is it acidic or alkaline? بديها من الآخر، اصبري. طب قولي لي بقى. طبعا acidic يا عبد الرحمن. بصوا كنزي كاتبه ايه؟ Yes يا كنزي. It is from 1.2 to 2. انتوا عارفين يا جماعه، thank you both of you. انتوا عارفين ان ال pH يا جماعه الاسيدك بتبقى from 0 to 7، والنيوترال بتبقى 7 لحد تقريبا 7.4، والبيزك بتبقى from 7 to 14. اوكي، ف these numbers they are found على ال pH meter we can know the pH from. ف in the stomach there is a gastric juice or the digestive juice. It is highly acidic كمان because it produces HCl, hydrochloric acid, with pH بتاعته from 1.2 to 2. فيبقى معناها that it is highly acidic, it's approaching the zero. فهنا we have an enzyme that works on protein. طيب قولي لي بقى يا فيرونيكا, this enzyme in which pH does it work? Acidic or neutral or alkaline? The enzyme found in the stomach.
Alkaline. Oh wait, no, acid, the stomach.
acidic طبعا. يبقى it needs an acidic pH. طيب عبد الرحمن, السلايفا. Saliva contains enzyme amylase that works on starch. pH of saliva is around 7.4. Is it alkaline, neutral, or acidic? The pH of saliva. It is neutral. Excellent. يبقى the amylase will work on neutral medium. Kenzie, in the duodenum, the pH is around 7.8. Enzymes that work here, for example, trypsin enzyme. In which medium does it work? Which pH?
Alkaline.
Alkaline طبعا. أو هنا بقى بنقول إيه؟ We call it slightly alkaline لأن بصي الالكالينيتي بتبقى تقريبا من 7.4 تقريبا، فأنا عندي 7.8 so it is slightly alkaline. طيب نخليها alkaline. Okay. What did you deduce from this? That there are some enzymes that work in acidic pH, others work in alkaline pH, but most of the enzymes, they work in neutral pH. Most, ده في human body by the way. Most of the enzymes, they work in a neutral pH. Some of them, they work in acidic, others work in alkaline. يبقى it's not like the temperature. التمبريتشر يا جماعة كان هنا الكومباريزن بقى إن temperature of the human enzymes, the optimum temperature, it's always the same, 37. That's why our blood is kept constant at 37 degrees. والبلد على فكرة هو اللي gives the temperature to the rest of the body. أو the heat, يعني the amount of heat. فبالنسبة للtemperature, all the enzymes of the humans, their optimum temperature is 37. But the pH, no. According to where the enzymes will act. Some of them are acidic, some of them are alkaline, but most of them, they are neutral. It means that the pH, the optimum pH is differing according to the medium in which the enzyme is found. If I want, for example, to put this picture for the pH. Now, again, look at this. Abdul Rahman, what is the independent variable here? We have to train ourselves على الجرافs من دلوقتي. What is the independent variable? It is the pH. Excellent. طيب وكنزي, what is the dependent variable?
The rate of the reaction.
Of course. Thank you. Now look at this. Look, these are two curves for two different enzymes. Okay. Now, what is the, Veronica, what is the optimum temperature for the red curve? The optimum pH for the red curve. It is how much?
Around 1.7.
Bravo, bravo. Around 1.7 طبعا. طيب, is it يا Veronica acidic or alkaline?
Acidic.
طبعا. بصوا هنا كاتبين ايه؟ Pepsin, this is the name of the enzyme, is a protease, يعني it acts on protein in the stomach because the stomach medium is highly acidic كمان 1.2 G or 1.7. This is highly acidic. طيب, عبد الرحمن, what about the blue curve? What's the optimum pH for this enzyme? For the blue enzyme, the blue curve, what's the optimum pH? It is around what? 6.5. Excellent. يعني it is nearly داخلة على 7. طيب, which pH, is it acidic, neutral, or alkaline? طب خلي بالك بقى، بص هنا بقول it is around 7. يعني أنا لو أخدت كده ال highest point، لا just a second كده، بص دي خلاص دي 6 slightly neutral، بص دي خلاص داخلة على 7، يعني it's only 1 square، قول مثلا 6.9 or 6.8. ف this is لأن أنا عندي هنا باخد كل small square ب 2، خلي بالكم this is 7، يبقى it's around 6.9. يبقى فعلا ما بقولش slightly neutral، بقول about neutral يا كنزي. ف it is تقريبا neutral. اوكي طيب يبقى بصوا مكتوب هنا ايه؟ most enzymes, as I just told you that most enzymes they work in a neutral medium, some work in an acidic, others work in an alkaline. عبد الرحمن طبعا you are correct ان less than 7 بتبقى acidic، بس هي it's not يعني most of the enzymes will work at 7 upward، يعني من 7 ل 7.4 بعتبره neutral. طبعا this curve ممكن يكون inaccurate، يعني المفروض يعني يكون عند ال 7، في slight difference ما بين ال 7 and the highest point on the curve. طيب أنا بقى عايزة أوريكم حاجة مهمة جدا. look at the blue curve عشان ده مش واضح. look at the blue curve. This is the optimum pH. خلوني أحطها تاني. Like this, for example. What if I decreased the pH يا كنزي? What happens to the enzyme? If I decreased the pH, what will happen to the enzyme from the curve?
It will be less active.
طيب هي الأكتيفيتي وصلت للزيرو بوينت ولا فوق الزيرو؟
هي المفروض عند الاكس اكسس، فممكن هي لمسه زيرو.
لا، ما انا هقول لك حاجه، الزيرو بتاع ايه؟ بتاع الواي. يعني this زيرو بيمشي مع الاكس اكسس والواي اكسس. اوكي، فهنا عند النقطه دي بالتحديد did the activity reach the x-axis or not؟
ايوه
ايوه طبعا. يبقى معنى كده the y is equal to what؟ يعني انا هنا مثلا if I give numbers here 1 2 3 4 and so on. اوكي، ف if I took عند مثلا ال pH of 5.9 على الواي اكسس الاكتيفيتي equal كام؟
2.
2. طيب لما ال pH تكون 4.8 what here؟ what is the reading على الواي اكسس؟ ما هي ما دام البوينت وصلت للاكس اكسس يبقى الواي على طول بكام؟
بزيرو.
زيرو. طيب يبقى what happened to the activity of the enzyme when I lowered the pH؟
inactive.
ده مش inactive، ده الاكتيفيتي وصلت زيرو، يبقى the enzyme was
denatured.
denatured على طول. اوكي، يبقى when I decrease the pH، بصوا عملت ازاي الكيرف، حصل a great decline، ده steep خالص، steep decline in the curve، كانت عالية قوي. بصوا نزلت فورا until it reached zero. ما دام the activity reached zero يبقى this is a denatured enzyme فورا.
طب مس هي opposite للتمبريتشر يعني؟
لا،
التمبريتشر لما
ما
بتوصل
انا هقول
لزيرو
لك حاجة بقى، التمبريتشر عشان كده بقول لك I'm comparing between them. هرجع لك التمبريتشر تاني بس نخلص ال pH. طيب عبد الرحمن، what if we increase the pH more than the normal temperature? What happens to the activity of the enzyme يا عبد الرحمن؟ If we increase the pH، ما هي lowered. طب what if the pH reached 10.5? What happens to the activity of the enzyme? بالتأكيد. And when the activity stops, so the enzyme is denatured. معايا؟ يبقى في ال pH is different from the temperature. في ال pH سواء we decreased the pH or increased the pH بتوصل الانزيم to be denatured in both cases when we decrease the pH and when we increase the pH. لو عايزين نكون more accurate هقول إن the activity will decrease أو will decline until it completely stops أو in other words the enzyme is denatured. And here is the same. The activity is declined or it is lowered gradually until the enzyme is denatured يعني the activity stopped. هنا whether I increase or decrease the pH بيوصل بينا إن the enzyme is denatured. What about temperature? Another comparison. Let me put again this curve. This one. وكنزي اللي كانت جاوبت عليه. Look here. If the temperature was lowered, what happens to the activity? Was it the enzyme was denatured or not? يلا يا فيرونيكا. When I decreased the temperature لحد ما وصلتها لزيرو, was the enzyme denatured?
No.
No. بصوا الكيرف فين؟ شايفه يا كنزي؟ This zero is for the x-axis and y-axis. Look at the enzyme activity. It is above zero. يبقى هنا this is the least activity of the enzyme. It did not reach zero. يعني the enzyme did not stop working when we lower the temperature. بس when we increase وصلنا للزيرو point بتاعت الواي ف the enzyme is denatured. يبقى in other words لما في temperature when we decrease the temperature the enzyme will decline its activity until it reaches the least activity. And when we increase the temperature the enzyme will be denatured, stop activity without any return. بالنسبة لل pH لا, whether we increase or decrease the pH the enzyme is denatured. ما عنديش حاجة اسمها activity will reach the least. لا. Enzyme is denatured whether the pH is increased or decreased in both cases. Here with the increase only in temperature. This is the difference between both. طيب أنا حابة أقول حاجة بقى كده very slight information على الانزيمز. إن الانزيمز يا جماعة we do not need many molecules of the enzymes to work. لا, we need very slight or small amount that is needed to change a lot of the substrate molecules into products. يعني أنا لما بيكون عندي substrate أو the material on which the enzyme will act, when the enzyme acts on it, I call the what is released the product or products. Okay? Right. How much enzymes do we need in order to break a number of substrate molecules? Very slight amount. يعني أنا هقول لكم كده example. يعني most of the enzymes we need one enzyme 1 gram أو milligram أنا آسفة 1 milligram of the enzymes to work for مثلا 1 million substrate. انتوا عارفين ان one enzyme can work the same reaction 1 million times in 1 minute. It means that we need very, very little amount of enzymes in order to make great number of reactions or to speed up great number of reactions. If I have مثلا 1 million substrate molecules, we just need one enzyme to work, one molecule of the enzyme to work on it. Because each molecule of the enzyme can work 1 million times every minute on the same substrate. We do not need يعني a great amount of enzymes. لا, it's only a little amount. طيب يلا كده نشوف يعني I explained before how the enzymes work لما عبد الرحمن قال لنا lock and key اهي reaction. طيب بيجي هنا question بقى how the substrate is directed towards the enzyme. يعني أنا قلت إن substrate it has a complementary shape to the enzyme. تعالوا نشوف how the substrate reaches the enzyme. بصوا بقى يا جماعة. We know من ال diffusion that all molecules are in continuous movement. Remember I said this in diffusion والosmosis والحاجات دي. All the molecules they are in continuous movement. طيب ما أنا عندي الإنزيم for example let me draw it like this الأكتيف سايت بتاعه طبعا normally الأكتيف سايت شكله مش كده بس ده بيبقى طبعا حاجة educative يعني. suppose the enzyme is found and I have many molecules around it. One is looking like this. One molecule is looking like this. One molecule is looking, for example, like this. Which one of them is going to fit? لو أنا قلت G1, 2, and 3. بالتأكيد number 2 is going to fit because it has a complementary shape to the active site of the enzyme. But why this molecule is going to fit in the enzyme when عندي several molecules and all of them they are in continuous movement وكمان the enzyme is in continuous movement. It means that all the molecules they are moving like this, like this, like this, like this, including the enzyme because the enzyme is protein. It is a molecule, so it's going to move here كمان continuous movement. طيب while there is continuous movement, so the kinetic energy is going to increase. طيب I have 3 different substrates and the enzyme. All of them, they are moving together. It means that they will collide together. تمام زي ما قلت في diffusion والosmosis. There is collision أو bumping between the molecules. So here all these different molecules and together with the enzyme, they are colliding together. وطبعا whenever they collide, so they gain more and more kinetic energy. During this collision, لازم in one substrate is going to hit the enzyme. If this molecule, this one, hit the enzyme, it's not going to fit, so it's going to regress back. If this molecule hit the enzyme, no, it's not going to fit. But what if this molecule hit the enzyme during the collision? It's going to fit immediately. فعلى طول during collision, this molecule is going to fit here and it will not regress backwards. يعني G, it doesn't have the same complementary site for the active site. So it will hit the enzyme and will return back. No, this is not my active site that I want to fit in. This molecule is going to bump into the enzyme as well because these are molecules. They are just colliding with each other. So it will collide and returns back. But what about this one? When it collides, it will fit. This is how the substrate fits in the enzyme. طيب, what else? خلاص كده chapter 5 finished. Chapter 5 finished يا جماعة. Is over يعني. Do you have any questions about الانزيمز مثلا؟ أنا حابة بس أقول حاجة هنا. What's meant by denatured? Denaturing of the enzyme. أنا لسه قايلة إن الكربوكسيل جروب والأمين جروب they are going to be destroyed. طيب ده معناه إيه بالنسبة للإنزيم؟ معناه إن الأكتيف سايت itself instead of looking like this it's going to look something else. يبقى كده الإنزيم is destroyed because its active site changed its nature or changed its shape. If you have any question would you like to ask me any question about this؟ في نقطة صغيرة برضو I'm going to mention، لكن طبعا I'm waiting for your questions if you have any questions. No questions. طيب حابة بس أقول حاجة صغيرة قوي على البكتيريا. البكتيريا يا جماعة، البكتيريا can live as you know anywhere. في بعض البكتيريا they live بقول عليها in extremes of temperature أو extreme of temperature. These bacteria they live in the hot springs. So what are the hot springs and what's the spring? Spring doesn't mean the spring season. لا, spring is a collection of water that looks like a well, لكن in the desert مثلا this is the spring. Okay, some collection of water looks like a well but shallower than the well of course. فبلاقي ان the hot springs or the temperature of water is very very hot. طبعا يا كنزي طبعا. فهنا ال very very hot water that reaches زي ما كنزي قالت 75 to 80 degrees and the bacteria are living there. طب why? Because the optimum temperature of their enzymes is 75 to 80 degrees Celsius. طيب في حاجة كمان إن بالنسبة للplants for example, plants can live مثلا in the very cold regions. الانزيمز of the plants زي ما قلت لكم قبل كده ان الoptimum temperature تبقى around 27 28. ده for the plants that are living in normal conditions, but there are some plants that can live in cold regions. ممكن الoptimum pH بتاعتهم توصل مثلا 15 to 20 optimum temperature، ودي ممكن توصل ل 27 to 30. اوكي يبقى ده في النورمال كونديشنز بتاعتهم. يعني in the desert مثلا it will be more طبعا than 30 التمبريتشر. طب ايه اللي بيخلي the temperature is about 30؟ ان طبعا في زي ما قلت قبل كده ان في chitin او a layer that covers the desert plants that reflects the sun heat. I mentioned this لما كنت بتكلم على السيل وول. قلت ان هي بتبقى الديزرت plants they are السيل وولز بتاعتهم made of chitin، وبتبقى نفس الكاكتس for example is covered from outside by a waxy layer that reflects the sun heat away from the plant. عشان كده temperature inside the plant بتفضل optimum for the bacteria for the enzymes. طيب أنا حابة بقى أقول حاجة على الهومورك يا جماعة. يعني أنا يمكن قلت لكنزي كانت هي أول واحدة she logged in في الكلاس. This week I'm going to send you 2 homework لأن إحنا دلوقتي we finished chapter which chapter did we finish now? Chapter 5. I didn't send على chapter 4 ولا الانزيمز. So this week I'm going to send you 2 homework. واحد على chapter 4, the other one على chapter 5. So please be committed to the due date. الديو date أنا لما بكتبه I write it for a reason because I have a schedule and I check the homework at certain days. بيبقى عندي some free time so I can check the homework. If you submitted the homework late, I will not be able to check it because this will take the place of other courses homework. يعني for example أنا بعمل checking ل OL for example on Friday، بعمل ل AS on Saturday for example. فلو أنا ما عملتش checking on Friday هضطر أعمله on Saturday. What will the AS students do? Please be committed to the deadline date or the due date of the homework. ولما أقول on مثلا Friday it doesn't mean Friday after midnight. During the day please so I can check it. خلاص فإن شاء الله see you next time. I'm going to send you 2 homework this week إن شاء الله. يبقى 4 sheets. Multiple
Dr.
choice.
regarding the exam.
الquiz. Sorry.
Yeah.
I'm going to make the quiz. خلاص احنا خلصنا chapter 5. I'm going to tell you, you have to study hard because I'm going to set up a date and we'll send you على الواتساب. When is the quiz going to be? And it's going to be a quiz to be done at home, مش online. I'm going to send you the quiz at a certain time. بديكم 1 hour to solve it. 1 hour to solve it and then submit it. يعني أنا بديكم ال 1 hour دي. I send the quiz مثلا at 15 minutes before 12 أو 15 minutes to 12. In order to let you print it out, at 12 exactly, you will begin your quiz. خلاص? I give you 1 hour to solve the quiz, and then I give you 15 minutes or half an hour to print it out, or to scan it and to send it. يعني I give you some time to submit your quiz. فأنا هديلكم كل الانستراكشنز دي على الواتساب. Okay? بالتفصيل. What are you going to do? Okay? Okay. No one is here to say okay. أنا عارفة the time is over. إيه الواتساب
Okay ماشي.
طيب
Okay,
أخيرا كلمتوني. عبد الرحمن هو اللي ما بيقوليش اوكي خالص ولا بيكتب ولا حاجه. طيب اوكي see you ان شاء الله next session. يلا باي باي. اوكي يا عبد الرحمن. باي باي.